Greetings, math fans. All right, so today what I'm going to do is just go over a couple more examples of what we did on day one. So this is day two. Because day one was kind of long notes, a lot of things, but I want to just, again, do a couple more difficult examples here. All right, so I want you to find the extrema. So you have f of x is equal to 2x parentheses x plus 3 to the 2/3 power. Okay, a little more complicated. No big deal. Okay, I'm going to stress here, math fans, totally stress that you guys have to be careful when you take a derivative. Okay, this is not like last chapter where you make a mistake because you have 20 problems on a test and you make one mistake and okay, no big deal. So you got one out of 20 wrong. And you got 95%. We're talking, if you make a mistake taking the derivative, that means all the information you're going to find out about that graph. We've only done critical points, maxes and mins, but we're going to do a lot more later. We're going to do intervals of increasing and decreasing and concavity. We're going to do all kinds of stuff. But if you mess up the first derivative, the whole problem's wrong. It's brutal to mess up on the first derivative. All right? So with that in mind, that I've scared you all now, let's do the first derivative. Of course, we're going to do the product rule, so it's the first times the derivative of the second. So 2/3 x plus 3 to the negative 1/3. Okay, of course, don't have to worry about the chain rule because the derivative of x plus 3 is just 1. Okay, plus the second times the derivative of the first. And so the derivative of the first is 2, and the second, the second is x plus 3 to the 2/3. Okay, so that's what you have so far. Now the deal is, you want to find the critical values, math fans. You can't leave it like that. Okay, you got to really put it under one fraction. You got to get rid of the negative exponents, kind of what we did back in the day. So I'm going to write this as 4x over 3 times x plus 3 to the 1/3 plus 2x plus 3 to the 2/3. Okay, that just simplifies that left-hand side there. And then let's put it into one fraction. So I'm going to multiply this side by 3 times x plus 3 to the 1/3. Or I get a common denominator, which our common denominator is 3x plus 3 to the 1/3. Okay, so we're going to have f prime of x. If we write all that stuff together here, we're going to get, do you guys agree? X plus 3 to the 2/3 times x plus 3 to the 1/3. That's kind of nice. That's just x plus 3. So really we have 4x plus, and 2 times 3 is 6, and that's x plus 3. And on the bottom is 3x plus 3 to the 1/3. Okay, and let's keep going here. Distribute that, and so we get 10x plus 18 over 3x plus 3 to the 1/3. All right, and now we're good to go because now I just set that equal to 0. Now this is the deal, math fans. Remember I told you back or day one, I said you find your candidates where the first derivative is 0 or undefined. Remember we talked about undefined being a cusp or a corner, right? There are possibilities for it to be undefined where it is a max or a min. And so that's what we have to do. We've got, let's do the 0 first. It's just going to be 10x. So let's write that out here. F prime of x equals 0. That's going to be 10x plus 18 equals 0. That's the top, right? When the top is 0, the whole thing is 0. So we solve for x, and we get x is equal to negative 9/5. And then we have f prime of x equals undefined. Okay, and that's just the bottom equals 0, right? So it's x plus 3 equals 0. So x equals negative 3. All right, so let's do our interval testing. We're going to have negative 3 here and negative 9/5 here. So I'm going to pick negative 4, negative 2, and 0 is a favorite number because it's easy to plug in. And remember, math fans, you're plugging this into the first derivative. That's huge. You got to find out what the slopes because you know the slopes of -3 and -9/5 are either 0 or undefined. I need to know what's going on either side of them. So if you plug in, you get positive, negative, and positive, because that's all I'm concerned about is just the signs. Okay, and what do you find here? Well, you find out that -30. Okay, that is going to be a relative. Take your hand, right? Positive, negative, so it's a relative max. And then this guy here, -9/5, that's a coordinate. If you plug it in, -9/5, gets a nasty decimal, so it's -4.07. That is going to be a relative, because again, take your hand, negative to positive, so it's a relative minimum. Okay? And this one actually has no absolute max or min. And it's actually tough to tell that from this plus minus plus, but the deal is this is a rational function. Okay? And okay, so let's talk about the absolute max and absolute min, the absolute extrema. If you look at this problem, it might be a little confusing, but you see a plus plus here. I want you guys to understand that what's going on here, even though I'm not showing you the graph right now, if it's a positive slope to a negative slope to a positive slope, look at that. Okay, look at that. So in other words, do you guys agree that there's no max and there's no min, there's no max, right? Absolute extrema here. If I talked about endpoints, if I had -5, let's say -5 to 5, there's still no absolute extrema, right? Because it's they're parentheses, right? Does that make sense? It's really an open interval when they're parentheses because you get closer and closer to that value, you never get to that value. Now, of course, if I have -5 to 5 in brackets, it's a different story. Then I actually need to check both of those values and my -3 and my -9/5. I have to check 4 values to see what's going on to figure out my absolute extrema. I just want to show you real quickly, math fans, what this graph looks like on your graphing calculator. Because we found our relative min and relative max. One was undefined and one was as 0 value, right? So let's plug this in here. If we have y equals, again, this is our original function, so 2x. I'm going to put all the stuff in parentheses here. It's just a lot easier. So 2x and then times x plus 3, close parentheses, raised to the parentheses 2/3 power. Okay? I'm going to do zoom 6. And look at that, man. That is what our graph looks like. So if you notice right here, see that -3? What was that that value of -3? That's where it was undefined. And that certainly looks like a cusp to me. All right, it goes up and then back down again. So that's a cusp, and then it's then a little bit over where it's -9/5. That's just a minimum value. Okay, that's where the slope is 0. So this is a really good graph of exactly kind of what's going on here. All right. Okay, so let's look at another problem here. This is an endpoint problem. And what I'm going to do is, first I'm going to give you guys the endpoints. It's going to be between -2 and 3. Okay, notice the brackets, which means what? We can probably have, there's a potential we can have an absolute max or min here. Certainly not relative, because you can have a relative extrema at an endpoint. All right, so let's start with our problem here. Y equals 2x times the square root of 9 minus x squared. Okay, so first thing I want to do is, you guys know it's easier if it's written this way, right? Just easier to take the derivative of. So you get y prime, it's the first times derivative of the second, so we get 2x times 1/2, 9 minus x squared to the -1/2, right? And then the chain rule gives us -2x. So that's the first times derivative of the second, plus the second times derivative of the first, which is plus 2 times 9 minus x squared to the 1/2. All right, let's put some stuff together here, get rid of the negative exponents. I get y prime is equal to -2x squared. over 9 minus x squared to the 1/2 plus 2 times 9 minus x squared to the 1/2. All right, and of course we want to put them together, get a common denominator, which is 9 minus x squared to the 1/2. So I'm going to multiply this guy by 9 minus x squared to the 1/2 over 9 minus x squared to the 1/2. So we get y prime is equal to negative 2x squared. Of course, 9 minus x squared to the 1/2 times 9 minus x squared to the 1/2 is just 9 minus x squared. So we get plus 2 times 9 minus x squared all over 9 minus x squared to the 1/2. Okay, and then let's simplify. You get y prime is equal to combine like terms or distribute and combine like terms. So we get negative 4x squared plus 18 over 9 minus x squared to the 1/2 power. All right, that's pretty reasonable. All right, so now, of course, you guys remember, you find your candidates by understanding where the first derivative is equal to 0 or undefined. So when you have f prime of x, let's do 0 first. That means the top, or the numerator, is going to be 0. So we get negative 4x squared plus 18 equals 0. So x squared equals 9 over, or 18 over 4. So x equals, if I rationalize that as well, I get plus or minus 3 root 2 over 2. Okay, and what about where f prime of x equals undefined? That means the bottom is equal to 0, so it's 9 minus x squared equals 0, so x squared equals 9, x equals plus or minus 3. Okay, so we got 4 values here. So let's do our interval testing. So we have negative 3. If we actually get the value of 3 root 2 over 2, it's like 2.1 approximately. So it's going to be negative 3 root 2 over 2. And this is going to be 3 root 2 over 2. And this is going to be positive 3. Now, I want to point out a couple things here, math fans. First of all, our endpoints, I'm going to write this out again, were negative 2, 3. So, and the original problem was, just write this down again, y equals 2x, the square root of 9 minus x squared. Okay. This is about negative, I said negative 2.1. So that's not even, that's beyond the endpoint, right? It's negative 2 to 3. So I don't even look at these. Do you guys agree with that? I don't even look at those values because they're not even in my domain. So the only ones I'm looking at are 3 root 2 over 2 and 3. But I got another issue here, right? I'm not even looking at this one here either. Why? It's an endpoint. It can't have a relative extreme at an endpoint. So really, out of all 4 of these, the only one that's going to really be a candidate is 3 root 2 over 2. Okay? And if I plug that, so f prime of 3 root 2 over 2, okay, of course we know that's 0, but so I'm going to check on either side here, right? I'm going to do, what can I do here? I'll do 0. 0 is a nice number, and since that's negative 2.1, I'm going to do, or 2.1, I'm going to do 2.5, 2.5. And if I check those values out, I wind up getting positive here, and I get negative here. Okay? So with all that information, that's all I really need. And you guys agree, take your hand. It's positive to a negative slope, so this is a relative max. Okay? So that's, and then if I get the coordinate, actually is going to be a relative max is 3 root 2 over 2 comma 9. It's a relative max. So let's talk about our absolute extrema now. What I tell you guys to do, well, this guy right here is definitely one of our candidates for absolute extrema because it's a relative extrema. Okay, but we're going to check endpoints. That's huge. Do not forget that. Okay, so I'm going to check f of negative 2. And remember, it's f of negative 2, not f prime, because I'm actually trying to find the y values. So that gives me, if I plug that in, I get negative 4 root 5. And if I check f of 3, I get 0. And that's approximately 8.94, the negative 4 root 5, just to kind of see where we're at here. All right, so I can tell now that's this is negative here. So that coordinate here, let me write it out, negative 2, negative 8.94. And this is 3, 0. So if I'm looking at my maximum y value, that is, this guy right here is my maximum y value. So this guy here is also an absolute max. Okay, if I look for my absolute min, it's going to be this guy right here, right? Let me highlight it here. This could be my absolute min. Okay, because it's my smallest, lowest y value. Okay, so absolute min. Okay, I want to graph this function too. I want to show you guys what it looks like. So it's, again, this is our original function. So it's going to be 2x and then times 9 minus x squared. And I know I could have just taken the square root of it, or I can raise it to the 1/2 power, or raise it to the 0.5 power. Okay, so I can hit zoom 6. Ah, very interesting. So notice here, math fans, it kind of has endpoints, though I actually restricted it, negative 2 to 3, because truly what the original endpoints should have been are from negative 3 to 3. If I didn't give you any endpoints, the actual endpoints would have been negative 3 to 3, and the reason is because look at the original function, right? It's 9 minus x squared. You can't have a negative square root, so the biggest number it could have been is 3. The smallest number is negative 3, because that would have been 0 under the square root. But the deal is I restricted it to negative 2, and that's why negative 2 actually turned out to be our absolute minimum at negative 8.94. Well, actually, just even looking, if I would have gone farther to negative 3, it would have actually gone up again, wouldn't it have? Okay, so it's just kind of interesting to investigate what's going on here. And then my absolute max is actually at that peak. Okay, if you look at that peak, because what happens when you get closer and closer to 3, it comes back down again. Okay, so that 3 and the negative 3 actually wouldn't have been any relative extrema. But I just wanted, that's why I added my own endpoints just to make it a little more interesting, see what's going on. Okay, very interesting. All right, I got one last thing I want to just show you guys. I'm going to talk about piecewise functions. All right, here's an example. If I give you a piecewise function, something like this, and if I just randomly said f of x and I said x plus 2 when x is less than 3, and this is just completely random, 2x minus 1 when x is greater than or equal to 3. Okay, that's a nice piecewise function. I want you guys to understand the m is different. And it's a continuous function at x equals 3, right? If I put a 3 into there, I get 5. And the top one, I put a 3 in the bottom one, I get 6 minus 1. I also get 5. It's got to be continuous in order to be any kind of relative extrema. But with the piecewise function, the slope is different, so that actually makes it a relative extrema. You guys agree with that? Because what's going on here is the slope is changing. And when the slope changes, in this case it's going to be a corner, right? You can have it relative extrema. As opposed to if I gave you something like this, where the graph looked like this, and then it changed here and it kept going, right? So this is linear here, this part's linear, and this part is quadratic, but the slopes are the same there. So if the slopes are the same, there's no relative extrema here. Okay, so just kind of keep that in mind about piecewise functions. If the slope is different and it's continuous, you you have some relative extrema at that point. Okay, that's it, math fans, for day 2. Just a couple more examples. Hope you learned a little bit more. Adios. Goodbye.